Okay. Well, thank you everybody for coming out tonight, for joining us. We'll get our chapter business meeting on the road here. I don't know why it's not changing slides. There we go. I'll call the business meeting to order. And we'll start with Vinnie reading our minutes from our September and October meetings. Or not?
Can you guys hear me?
There
now?
it is.
Yes,
We
we can.
did, and then you cut out.
All right. I
There,
don't know what's going
got
on.
you now.
But all right. So we need September meeting. Call to order at 7:06 by Tom. Minutes of the July meeting were read. A motion to approve by Jim Peck, seconded by Dean Leeson. Motion passed. Treasurer's report. We have a static financial situation. No income other than national rebate, no outflow. Motion to approve by George Braungard, seconded by Vinnie. Motion passed. In frequency coordination, Gary received a call for an event on Irving Place. It was not the Irving Place in Syracuse, but New York City. Referred to the Chapter 15 coordinators. In certification and old business, nothing to report. In new business, meetings remain virtual till further notice. October 20th will be leader instruments, November 17th to be announced. National elections are complete. Several webinars are upcoming. Under Expo, we have a contract. Minor differences are apparent. Tom will send to officers in a couple of days. If anyone is interested in helping with the Expo, contact Tom. There will be a memorial gathering for Roy Taylor at the 10 Pin at 1 o'clock on Saturday. Tom and Vinnie will be attending. We have a plaque to present to the family. A motion to adjourn at 7:18 by Tom, seconded by Gary Hartman. Motion passed. The program for the evening was Don Roberts of Sinclair Broadcast Group presenting the new Regional Sports Networks Operations Center. And that's it for September. Any comments, questions, changes?
Nope.
Can we get a chapter 22 member to make a motion to accept the minutes?
I'll make the
Make
motion.
motion. I'll second that motion.
We
All
got,
right. I got Dean and Pete. Am I right?
That's correct.
Affirmative.
good.
Chapter
All right.
22 members, all in favor, say aye.
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 Opposed, nay. Yeah, oh, you've still got another set of notes to read, so
Yes,
I jumped the
indeed.
gun. I jumped the gun here.
Not done yet. Meeting was called to order at 7:06 by Tom. No minutes from the September meeting were available. We will try to have those available at our November meeting. Treasurer's report by Gary Hartman. No expenditures in October other than credit card monthly fees. Motion to accept by Dean Leeson, seconded by Pete Peters. Motion approved. Frequency coordination and certification by Gary. Nothing to report. Tom announced upcoming meeting dates of November 17th and December 15th. No presentations scheduled yet. Tom is looking for suggestions. Dean Leeson told Tom he should call him to discuss. Jim Peck is checking around too. New business. Roy Taylor's family held a private memorial for Roy at the 10 Pin on Saturday, September 15th. It's not a bowling alley, it's a restaurant. I'll fix that. Tom and Vinnie were invited and presented a plaque to the family in memory of Roy for them to either take home or hang in the 10 Pin. We're not sure what they decided to do with it. Tom went over notes from Jim Ragsdale, National SBE Executive Director, mentioning upcoming Ennis workshop in Atlanta, upcoming webinars, and a reminder of certification test date deadlines. Tom discussed the 2020 Expo. The Ramada contract proposal has been forwarded to the chapter officers. Vinnie forwarded to Chris Imlay, legal counsel at National, for review. Tom is waiting to hear back from all. We will shortly sign thereafter and send a deposit. Website Expo section updates are in progress. Meetings for the expo will take place after the holidays. They could use some help. Contact Tom if interested. A motion to close the meeting at 7:12 by Tom McNichol, seconded by George Brongard. Motion accepted. And the program, Steve Holmes from Leader Electronics presented monitoring video and audio ancillary data in a hybrid SDI IP world. Any changes, corrections, additions, comments?
We have a chapter 22 member, make a motion to accept.
I move that we accept.
Pete Peters, who would like to second that?
I'll second it. Anna
Anna
Marie.
Marie. All in favor, aye?
Aye.
Aye. Opposed,
Aye.
nay? Okay, let's move on to treasurer's report. Gary.
Well, our financial situation is exactly the same as it was last month, except for a few dollars less for the monthly fees.
I'll make a motion to accept the treasurer's report. Would like to second that.
I'll second it.
Any? All in favor, aye?
Aye.
Opposed, nay? Gary, frequency coordination and certification.
Absolutely nothing to report on either one.
Does anybody have any other old business? No, move on to new business. We do have a meeting lined up for December. It'll be Wednesday, December 15th. Miguel Perez from Burke Technology is presenting simple, scalable, secure remote site access in the NOC and in the field. And then we'll be setting up something soon for January, and that'll be January 19th. And then the meeting after that will be February 16th. We don't have anything for that yet. If you have ideas, send them along. Jim Peck's been helping us out, and I appreciate that. Help you, Jim. Thank you, Jim, for giving us some ideas. I will get the announcement out about December's meeting probably by the end of this week. Here's some notes from Jim Ragsdale. These are a lot more extensive than what Jim Porter used to send, so I'll just put the PowerPoint up here and let you guys read what you want to out of it. A lot of it was presented in the introduction as you were logging into the meeting. Pretty much the same stuff. Here are upcoming webinars. One is tomorrow and then 2 in December. And then Ennis workshop planned for the spring. Where is that one? You've got a few on the calendar: South Carolina, Michigan, and Louisiana. So more details on that will be coming, I'm sure. And SBE mentors are needed. Go to the SBE website, found out, and you can find out more about that, or contact Kathy or Rose at the SBE National Office. As far as the expo goes, I just got back notes from Chris Imlay today that Vinny forwarded over to me. He had quite an extensive list of things we need to look at in the contract, and I'll go through that tomorrow. Gary has sent his suggestions over, and I'll be looking at both and probably coming up with some changes we'd like to make and sending them over to Kate at the Ramada and see if they can accommodate us with those changes. Other than that, we're pretty much on hold until we get a contract signed, and then we'll ramp things up after the holidays and start getting word out and hopefully signing up exhibitors. In the past, except for last year, we've had a holiday get-together, chapter get-together. Is there any interest in doing that this year, or would you rather just wait until next year? Thoughts, ideas?
Speaking for myself, I think it's a little premature.
Yeah,
Yeah, okay.
agreed.
Not that I don't want to have a drink or two and a good meal with you guys, but not now, thank you.
I feel the same way.
Okay,
The organizations I belong to, we've kiboshed it for this year, so.
yeah, I would just assume wait another year, and then hopefully after the expo, we'll have a little more income too, so. Okay. Check that one off. And then just a reminder, officer elections come up in June. This is the last term for me, Vinny, and Kevin. We can each serve 3 2-year terms, and by June, we'll have done that. So give it some thought as to who you'd like to run for elections, officer elections. And I will, at some point before then, appoint somebody to chair a committee, a nominations committee. And I think that's all I have. Probably be a while before we go back to in-person meetings. Any thoughts? I know, I doubt that Sinclair's going to let us in the building yet, right, Denny? So if we have in-person meetings, we'd have to go somewhere else.
I think once we do start in-person meetings, we should keep the virtual part going too.
Yeah. So there's an option for those that aren't comfortable with attending. I agree. And at some point, you know, in late winter, early spring, we might be able to do a tour of a facility somewhere and get together that way. Does anybody have anything else they'd like to discuss? Not, I'll make the motion to close the chapter 22 business meeting. We have a second.
I'll second.
Everybody seconded it. Let's get it over with. All in favor? Aye. Opposed, say nay.
Aye.
And for anybody that's not a chapter 22 member, do you have anything you'd like to discuss? Anything going on in your workplace or in the industry you'd like to talk about before we get into our presentation? Other than ransomware attacks, I'm sure Vinny doesn't want to talk about that.
No.
Yeah, the ransomware that happened to Madison last month when we were talking with those guys, they had just experienced that. So I'm assuming, Vinny, you're in the same ballpark then, eh?
We had one that was almost 2 years ago now. It'll be 2 years in January. That was fun, but we caught
Really?
it quick enough and disconnected the culprit computer from the network and stopped the spread. So,
Wow.
yeah.
We
Out
were
there.
attacked by ransomware. We were moving into our new facility, which I'll have pictures of, but we were moving into our new facility the next week, combining 2 operations into one. And suddenly there was a ransomware attack that, I mean, to this day, we still kind of feel the ramifications of it. It was
Yeah.
very sophisticated, and our IT guys would come up with a defense, and then the ransomware gentleman would contact us and say, "We know what you're doing. Your ransom is going up."
Wow.
Fascinating. Well, I had to do paper and pencil, which a lot of people weren't familiar with.
Yeah. There's a lot of transmitter thefts going on right now too. I got an email from our COO today that 3 stations in the group were hit, their transmitter sites.
Wow.
So he wanted us to ramp up security, and finally got the security camera system I've been asking for 3 years. I ordered it today. So, anybody got anything else? If not, we'll move on to our presentation. We welcome Chris Cleary from
All
Seiko
right.
Energy Products, and I'll let you take it away. I'll stop sharing my
All right.
screen.
Let me see if
And
I
you'll
can
be able to
share
share yours.
mine. Here we go. Now let me fix the slideshow.
It's coming in.
All right, everybody can see that okay?
Yes.
All right, together we power on. Well, hey, appreciate you having me tonight to talk about lithium ion batteries and broadcast applications. It's it's got good technical information in it that I think you'll like, and that we've had a good reception from a number of other the SBE chapters for whom we've made this presentation. So I'll get right into it so that we can get to the meat of the situation. So for you guys who don't know, or anybody who doesn't know who Staco Energy Products is, we started off about over 80 years ago making variable transformers. Started making those, added those into, which pretty much, I would imagine that most people are familiar with those items. The lingo that's used is a variac or something like that, but variable voltage transformers is what we make. We make them in the Miamisburg, Ohio facility, just south of Dayton, Ohio. And the picture at the bottom here is a picture of our new facility. I mean, it's almost 3 years old now, so I wouldn't call that very new, but still new to us, I guess. And expanding as we speak. We're adding on another 40,000 square feet to the back, where we'll be storing some products, UPSs, and some custom enclosure solutions that we've been working on. So you're probably familiar with these big gray regulators. You might have some of these out at your transmitters, but that's they contain our variable transformers that are made again in the Ohio facility. And you're all invited to come by to our place. We're wide open. You can come in and visit. We can give you a tour of the facility. And one of our engineers is very involved with the Dayton, Ohio ham venture. They haven't had it for the last couple of years, but I understand it's quite the mecca for broadcast engineers. And Bob is high up on the food chain. And if you come in for a tour of the facility, then oftentimes, you know, and it's the same weekend that the hamvention is happening, oftentimes you can get together with Bob, and Bob can take you behind the scenes of the hamvention that happens at a local county fairgrounds. Some of our customers, we've got, you know, the big ones. Everybody wants to mention the guys who are popular, like Amazon and Microsoft. We've got them in Sephora, which is a retail place, as well as Tesla. They use our voltage regulators on some of their production pieces of equipment. And seeing a lot of interest lately in the electric charging station, so the electric vehicle infrastructure, where we're getting a lot of testing requirements for those. Briefly, to give you an overview, because lots of time I found in the past at some of the other SBE meetings that people were very familiar with our regulator product line, but not necessarily some of the UPSs that we do. We do single phase UPS, a couple of different sizes, very small rack mountable units. I believe the guys down in Christopher down in San Antonio has a few of those. The 6 and 10 kVA models. Then we've got our first 3-phase model, which comes in the 10 to 60 kVA sizing, typically the 208 input, but we can also, with adding transformers on the input and output, get it to whatever regulation you need. We also have, these are kind of exciting ones. These are explosion proof and hazardous environment rated UPS systems. Typically, they're used in the petroleum fields, like down in Houston, also in Mexico and the Gulf of Mexico. Pretty harsh environments. We also do custom applications. This unit on the right here is a stainless steel enclosure with an air conditioner, and these are used at the border, just a few 100 miles south of me. And they're used at the border to run the X-ray machines for the semis as they come across the U.S.-Mexico border. They use them in infrequently in other locations, but the most popular are along the U.S.-Mexico border. That's got a small UPS in it that's rated for outdoor applications from, like, I don't know, minus 20 degrees to 120 degrees. This unit here is one of our more popular units designed to compete with the big boys like a Liebert or Vertiv or whatever they call themselves now. And these units here, the first line Ps, when the repack was done a few years back, we got a lot of applications that were putting in digital transmitters that needed regulation, voltage regulation. And these are all electronic units that were put into place. Number of places had them. Orlando, Fox TV down in Orlando. We had applications in Little Rock, Arkansas. We had also down in Louisiana. There was a number of those applications there. Again, these are designed to compete with some of the big boys and hopefully take a little bit of that business. We also have emergency lighting. One of the requirements that we're seeing now for, especially for new construction, and actually if you're doing any type of refurb construction, is the need for emergency lighting to keep lights on for 90 minutes. This standard, the UL 924 product standard, has that the UPSs are sized to keep the lights on for 90 minutes in a facility. So for example, our facility, we just still have the bug lights. We don't have the UL 924 styles, but for example, in a TJ Maxx warehouse in Columbus, Ohio, they have these type of UPSs that back up their emergency lighting so that they can safely get everybody out of the building should they need to. We also have a 3-phase in addition to the single-phase ones. Again, the same application, only bigger. Now, one of the things I need to point out is that all of those products are available from our good friend Jim Peck from SCMS. SCMS is an excellent partner with Staco Energy Products, and Jim can help out with technical details or availability on any of those lines. So lithium-ion batteries, this is the most exciting stuff that we're seeing out there. We're seeing a lot of people asking about lithium-ion compared to the valve-regulated lead acid batteries. And so what we're going to do is kind of go over some of the technical details, a little bit of history, and then what I think is kind of the most interesting thing is the case study at the end, where we talk about comparison between a direct comparison in an application between the valve regulated lead acid batteries and the lithium ion batteries. So that's kind of what we'll go over lead acid solutions right now, lithium ion batteries and some of their configurations, and then the case study. SAFT now, okay, and in total honesty, Staco does not make the batteries. There's only a few guys in the world that make the batteries, and we use SAFT batteries. SAFT has a manufacturing facility down in Jacksonville, Florida, and we purchase them from those guys and integrate them with our UPSs. Okay, so why are batteries important? For obvious reasons. To back up your power, you know, they keep your power stable coming into, say, a transmitter, because obviously that's a critical load. You don't want to have your transmitter down losing revenue or anything like that. Now, typically the UPSs are used until a genset comes on board, and that could be anywhere from 10 seconds to 10 minutes, depending on the actual genset itself. And then, of course, you've got the switch gear from the utility that will come in last. But the weakest link of any continuous power system is the lead acid battery, which you'll see in a few minutes. One of the interesting things about lead acid batteries is that if you notice this configuration here on the left from Gaston Plante, that this is very similar to what lead acid batteries look like today, you know, over 150 years later. So not much in terms of change in the design. They're a solid, well-known commodity and used in a lot of different places. People are very familiar with them. But of course, there could be improvements. One of the first improvements was with nickel cadmium batteries. Again, over 100 years ago, invented. We don't have a picture of those, just the smiling fellow who invented them. Now, just to go over some of the details about the batteries that we have, you've got amp hours, which defined as obviously 1 amp of current for 1 hour. It becomes the amp hours. Typically, we're using 9 or 12 amp hour batteries, particularly at the in the VRLA level. You've got the temperature rating is very important for the batteries, because the hotter they are, the less amp hours they drain off their stored power, which becomes problematic in terms of when they're needed. So we've got 3 different species, I guess you would call it, of your UPS lead acid batteries. You've got the valve regulated batteries that are rated for 10 years. You've got the 20-year VRLA batteries, and then the 20-year wet cell batteries. One of the things that you'll hear is that the lead acid batteries are maintenance free. They're really not. They typically need monthly checks, monthly calibration. They've got to get looked at quite frequently, and can fail at any time. So you could look at them on a Tuesday and they're running just fine, and then have one of the cells go out on Wednesday and have to replace the battery. But even with good, if you didn't use them at all, they'd last 10 years. With regular maintenance and paying attention to the life of the batteries, keep them in an air-conditioned room, they're going to last about 3 to 5 years, maybe 6 or 7 if you get lucky. But typically, for most UPSs, you're going to get 3 to 5 years out of those. Now, one of the things that you do want to have is down the bottom, it mentions about a battery monitoring system. You can have remote battery monitoring systems that can assess continually the quality of the batteries, and then send out some type of an alert, either via text or phone call or email, that something's wrong with one of the battery strings. Now, the other VRLA technology is the 20-year batteries. Again, 20 years is a term that's used loosely, and you'll get a 9 to 12-year life out of these items. Because what you'll have is, obviously the batteries are used to back up the power, and there'll be dips into the battery. The electronics that come along with the UPS and that make up the UPS combined with the batteries can only regulate within a particular window. If you go outside that window, then the item stops regulating. And if you lose power for like even fractions of a second or a few seconds, now you're dipping into the batteries. Each time you dip into the batteries, you're reducing the life of the battery itself. Hence why we say that they're typically only going to be good for 9 to 12 years on the 20-year batteries, and 3 to 5 years for the 10-year batteries. One of these, the 20-year batteries, they fail on the front. So you can see along the front of the unit, where'd my mouse go? There we go. On the front of the unit here is where it's indicated to a technician where the failure is. So you could see right there that when a unit goes, as opposed to with the 10-year batteries, it's typically located on the top. So you have to pull out the individual strings and take a look at them. A little bit of extra work to take them out. Here, they're a little bit easier to see. And then finally, you have the wet cell batteries. And again, extremely reliable, a little bit messy to handle. They're high maintenance. You need eye wash stations. You need body showers. You need these desiccants down the bottom, these sandbags that will absorb should anything leak. And they cost about 3 or 4 times more than the 10-year batteries. You will get more life out of them, but again, all your safety measures that you have to have in place will make up for that. So as more batteries become more and more prevalent around the country and around the world, you've got more and more regulations that come into play to keep people safe and to keep the systems from maybe taking down the actual facility that they're designed to protect. So one of the leading states for regulations is California, and they define what thermal runaway is, and that you have to have systems in place to keep thermal runaway from happening. Thermal runaway will be, hey, the battery just keeps on heating up and heating up and heating up, and then eventually you get this happening. You can see how down here in the middle of the battery pack there, you can see where it started to melt, and you can see it probably erupted into a fire at some point in time, but the entire string of batteries are now destroyed and need to be replaced. So benefits of lead acid batteries. People know them, very familiar with them. We have them in our automobiles. We have them in all sorts of other different places, in addition to being used for a UPS application. They're a known entity, whether that's good or bad. You do get recycling out of them in terms of the scrap value for the lead. There's some copper in there. There's some other types of chemicals in there that can be recycled. Now, the cons kind of, in our opinion, outweigh the benefits, but you've got unpredictable performance. Everybody's had a car battery go out on them. It was good one day, then it's bad the next day, and it's only 3 years old. So, and it's supposed to be one of the maintenance-free ones, as I mentioned. There's really not an affordable or very accurate battery monitoring system for the lead acid batteries. You can get them, but they're rather cumbersome. The batteries are also temperature sensitive. They need to be kept at or below 77 degrees so that you optimize their life. They take a while to recharge, and you've only got a certain number of recharges that you can do to them. Plus, they're heavy and they require frequent maintenance. Now, if you notice, this picture on the left looks pretty much the same as what the picture for a plant did from 150 plus years ago. So the technology really hasn't changed all that much in terms of how you make a typical lead acid battery. And you can see on the right-hand side here how it works. You've got the electrolyte and the cathode, where you've got the positive ion flow, and the positive ion flow if you're an engineer, and the whole flow if you're a physicist. It depends on which you are. But the technology is the same as it was when Gaston invented it. Now, here's what we got. Now we've got a couple of different constructions for your lithium batteries. You've got the cathode powder, which is what we talk about typically with the lithium. And then you've got the cylindrical styles these ones here are probably about, maybe an inch in diameter and probably about 6 inches long or so. You've got the next size up, which is about 1.5 feet by maybe an inch or so in diameter. And these are the most prevalent. And then you've got your pouch cells, which are, basically, pouches that are filled with the materials, the cathodes. So let's see, I think the next one shows a better picture of it. So here, again, we've got the cylindrical batteries, but the lithium ion batteries were invented about 45 or 50 years ago, back in 1976, by an Exxon researcher. And then Sony introduced the first lithium ion battery in this format, this 18650, which is the cylindrical format. And then shortly thereafter, Saft produced commercially available lithium ion batteries. So they've been at it for quite some time now, nearly 30 years producing lithium ion batteries for applications. Now, and this data is kind of old, so I imagine that's probably changed a little bit with lithium ion taking up a bigger chunk of the marketplace than it does in this particular slide. But, it's got around 40% of the marketplace. Just think of where lithium ion batteries are used. They're used all over the place. Medical devices. They're used in they're used in my lawnmower and my weed whacker. They're in my phone. They're in my computer, in addition to being in Teslas and electric vehicles produced by Ford, GM, and everybody else in between. So they have a lot of presence around the world. You've got the starter batteries, which what we call those, you know, the like for your cars, to start your car or to start a truck or to a fork truck or something like that. So you've got those lead acid batteries. And then you've got your standby alkaline batteries, your stationary batteries, which would be in the UPS market. So, but you can see the type of marketplace presence that the lithium ion batteries have. Excuse me. Now you've got a number of different flavors. So when you talk lithium ion, that's kind of a generic term. It's like saying, you know, Vaseline or Kleenex. You know, for Vaseline for petroleum jelly and Kleenex for a tissue. When you say lithium ion, the ion could be a number of different chemical elements. You know, for example, you've got cobalt oxide, which we call LCO. That's typically used in your cell phone, your tablets, or some type of a camera, a handheld camera or something to that effect. Then you've got your nickel, cobalt, aluminum that's used in industrial applications, like, for example, fork trucks or electric vehicles. Magnesium, cobalt, again, you can see it's different applications because of how these combinations of the ion works with the lithium. So to put it together, it's a combination of its energy, plus its life, plus its safety, how much power it puts out. And you can see the differences on the graph right here at the bottom, where different combinations, I can't quite see what over here on the right-hand side, what the different chemicals are, but you can see that some have a lower voltage, but a longer life, a bigger window. Their capacity increases and goes into a higher realm over that way. Now, these these current cathodes that we use that we refer to up here are being supplanted by some new technology with this lithium titanate oxide and some silicon and tin base, mostly with improving safety. You know, everybody's heard of, you know, the hoverboards that exploded or the Galaxy phones that exploded and caught fire and things like that. Now, a lot of those could be traced to people literally buying secondhand lithium ion batteries and then just refurbishing them and putting them into a particular application that may or may not have been where they should be. So anyway, so a couple things to be traded off here. You've got your NMC batteries, nickel, magnesium, cobalt. You can see the power density is excellent. The energy density is excellent, but they're not too safe. Okay, so there's a trade-off there. If you need a higher margin of safety, you might be looking at the lithium magnesium oxide ones, which have a higher safety margin, operate good at low temperatures, not very good at high temperatures. They've got an excellent power density. The NCA, the nickel, cobalt, aluminum, they have an excellent calendar life, but again, not much in the safety department. I believe that those are the ones that are, believe it or not, that are typically used in vehicles like Tesla. Forewarned is forearmed, right? And then you've got your LFP batteries, which are the safest ones going. They really emphasize the safety aspect, but lose a little bit on the temperature aspect out that way. So really kind of a limited application for those guys, but they are extremely safe. So cylindrical batteries, the 186650 style or the 26650 style are typically the best performing best performing packages for the lithium ion batteries. They allow for the best expansion, the best performance. They adjust the best for given certain conditions. Plus, there's less handling at the factory, which makes it rather nice. The prismatic, prismatic cells, again, kind of a little bit different. They have thermal barriers in them. And then The pouches, which are down here a little bit further, they are difficult to seal. They're put together. They have their own trade-offs as well. So the most popular is the cylindrical style for most applications, though you do have the pouch batteries that are used for larger applications, like in some electric vehicles, electric trucks and things like that. So again, you can see the different modules that you have. You have common voltages, which match up with the VRLA style, which is the 12 volt, the 24 volt, the 36 and 48. Those are the most common. Typically, you're going to see a 24 volt application, something like this blue package down here, which is just filled with the cylindrical style batteries. Now, the battery management system is a little bit easier to handle for the VRLA batteries. It allows you to monitor a number of different aspects of the actual system itself, the lithium ion system itself. You can look at what the voltage of the cells are, what their minimums have been, what their maximums have been, number of faults that they've had, what the remaining capacity is, how many discharges, what kind of remaining energy they have. One of the key advantages of the lithium ion battery is its ability to discharge and recharge thousands of times, so that it's actually an order of magnitude better than the VRLA batteries, which typically run maybe a couple hundred cycles, 95 to 100 to maybe 150 full discharge to recharge cycles. So here we've got an example of what a battery management module would look like, where you're monitoring strings of the lithium ion batteries. Center Ion is the trade name for one of the battery packages that SAFT has. But you can see you're able to do communication and power and monitor both through this master battery management module. That allows you to, again, keep track of what the lithium ion batteries are doing. But by the same token, you'll see in the case study that there's not much maintenance involved with the lithium ion batteries when compared directly to the VRLA batteries. So for example, here's how you would set up how you could scale different sizes of the flex ion batteries. You go more voltage, you get a longer string, and then you add strings together so that you can get more power. So more voltage this way, more power this way. So this would give you, 500 kilowatts for 5 minutes, which would allow for, say, an orderly shutdown. It would allow for something like that, but only 4 strings of battery versus more string. You would use much more strings of batteries for a VRLA footprint that had to do 500 kilowatts. Again, these standards are a little bit out of date, I think, because they're dated 2010, so 10 or 11 years ago. And they talk about how they're going to take care of or monitor the lithium ion batteries in terms of what their construction is, how much energy they store, how they define those. But again, kind of very fluid documents, because we're learning so much more and more about the different chemical structures and how these units actually react in the field itself. So always important for something like that. So again, going back to the chemistries of the units themselves, you've got a couple different things that you have to consider. First of all, your materials that you're going to use, what type of environment that it's in, what type of atmosphere there's going to be there. It's, is it a dirty atmosphere? Is it a clean? Sometimes these so-called clean and industrial areas are not really clean once you've been in them for a while. You've got your different chemistries that you can select. Again, depending, you got to balance your safety. You've got to balance your performance. Is it Is power important? Is energy important? Is high temperature, low temperature, safety, et cetera? How you're actually doing those, that design. And then, of course, the cells, how you'd put those together. You get what kind of a, you can use pouches. Will you be using the cylindrical style of the two cylindrical styles, which has more appeal, the 18-6650 or the 26-650. And again, your overall system. So from those, you get your entire package of what the batteries would look like, lithium ion batteries would look like. So you could use this is an important chart right here, because this shows where your standard lead acid battery fits on this scale in terms of its power and energy. It's kind of limited in what it does. Again, it's very well known. You can stack those together. Nobody typically gets fired for selecting a VRLA battery for a particular application. We have thousands of them in the field in various different industries and at transmitter sites. Again, you've got nickel cadmium that was an improvement upon the lead acid batteries. That moves it a little bit further down the scale in terms of energy and power. Then you've got other chemistries that are trying to improve upon those. But look at the range of the lithium ion batteries. Again, lithium ion, depending on what the ion chemistry is, it would change. But you can see you need high energy. Here you have the furthest on the right in the light blue there, you've got the VLE energy, high energy lithium ion batteries there, down to ones that are ultra high power that are used for different applications. So you've got different ranges, all sorts of flexibility in terms of what your design is, and a higher range for a particular application. Of course, we are talking about stationary batteries, so those have a different chemistry that's designed for that. So they fit more in this area right here. Now to the case study that we have. This was done at a facility, I believe it was down in Florida, because it happened to be close to Jacksonville, where SAFT actually makes their batteries, and it was for a data center. 500, I believe it was 500 kW, and they did them in parallel. So they had the lithium ion batteries and the VRLA batteries at the same location, doing the same operations under the same conditions. So they had the voltage range you can see there was from 400 to 564 volts. You had a temperature range that went from 15 to 35 degrees, so pretty nominal type of application. There, it was indoors, of course, not outdoors. The lifetime was expected to be 15 years with the end of life criteria with 70% of the capacity remaining. So we compared the VRLA batteries and the lithium ion batteries, the flex ion. Here's what the results were of the actual testing itself. You can see that the high power lead acid batteries gave about 29 kilowatt hours. They had a 21 square foot footprint, which was twice as big as the lithium ion batteries. Look at the difference in weight, 13,000 pounds for the lead acid batteries versus 2,500 pounds for the lithium ion batteries. Significant difference there in terms of how you're gonna position these things, where you can put them. Imagine lugging 13,000 pounds of batteries into a particular location. That's not something I really would be looking forward to. The calendar life for the VRLA batteries was calculated to be 5 to 7 years. For the lithium ion batteries, it worked out to be 20 years. Your total cost of operation for the unit was significantly less, as there was less maintenance involved. Didn't have to look at them every month. It was a couple of hours that somebody looked at them just to make sure that they were doing what they were supposed to be doing and nothing was going wrong. but each of the lead acid batteries had to be examined monthly extensively because they were put in on shelves. So they were the 10-year lithium VRLA batteries. So you have to look at the top of them. So you have to pull them out of the shelves each time a technician has to go in there. So it is a rather tedious operation. But overall, the total cost for the lithium ion batteries in a particular application for this 500 kW application worked out to be that the lithium ion batteries, despite being more expensive to purchase at the beginning, the savings in terms of real estate, in terms of maintenance, in terms of lifetime was significant. We'll probably repeat this again with a different chemistry just to see what kind of results we have, but because this happened, I believe it was completed 3 or 4 years ago. So, but you can see, again, this kind of just summarizes what the benefits were. 8 times lighter installed weight. You had 4 times smaller installed footprint, greater efficiency in terms of a round trip. A round trip would be from going to full discharge to recharge again. They're much more efficient that way. They charge, the lithium ion batteries charge much faster, 5 times faster than the lead acid batteries. Again, they can do 3,500 cycles of deep discharge recharging. So you can discharge them to 80% level and then get back up to so that they're 80%, so 20% capacity. You can do 3,500 times down to 20% capacity, then recharge them back up again to full capacity, and they'll work without a hitch. You can't do that with the VRLA batteries. It's about 1/10 of that. 20-year life at room temperature. That for all batteries, that's rather important to keep them at room temperature or keep them in a controlled environment. And that's pretty much all I had in terms of what the lithium ion batteries, what their technology is, what we're looking at for the future, what we've seen in the past. We've got a couple of applications now in industrial applications for the lithium ion batteries where they're backing up material handling systems. So be glad to entertain any questions you guys might have or comments or something I missed, or stop that share and go back to you.
Hey, Chris, Jim Peck, thanks very much. A couple of questions on the 15-year cycle that you were doing. Was that an actual calendar 15-year, or did you have an estimated based on an accelerated life cycle?
The latter, not the former. It was actually estimated based on an accelerated life cycle.
Okay. With lithium being in such demand, and obviously other countries having the same interests as we do, while it's primarily, in your case, a SAFT problem, it's only one step away from your door.
Right.
What kind of future limitations do you see on product development based on demand from others, making it more difficult to get the raw materials necessary to make the systems?
Getting the raw materials has certainly been a challenge. SAFT has some of its own mining facilities, believe it or not, that they own across the world that helps them have a direct supply chain for the lithium rather. So they haven't seen too many effects right now, but with looking at different technologies, which they have in their R&D facility down in Jacksonville, they're looking at other configurations that might work better, that might optimize it better so that they're not as dependent on one particular chemical or one particular chemistry, so that we have, so you have greater variety and can actually, keep battery production going. It does take some time to configure the batteries. I believe that the lead time right now is running around 16 weeks to get some batteries together, which to me, that seems kind of a long time, 4 months to receive something, but that's just how it's been working out lately. Hopefully to improve.
You have any,
Go ahead. Okay. Yeah, at the end of the life of the battery, are these batteries, are any part of them recyclable, or are they just?
I couldn't quite, it was breaking up for when I was listening. Try again. Was that you, Tom?
Yes.
Oh, there we go.
The end of life on these batteries, are any parts of them recyclable, or they just go?
Tom, you're breaking up terribly.
That's
Are parts of them recyclable? Yes. There's a very specific process that you have to go through in terms of handling them and recycling them, because they are, how shall I say it, explosive. Yes, they in the right environments, they are explosive and they're delicate to handle. Typically, when we've gone on startups for these lithium ion batteries, when we're first putting them in, the handler is in full personal protective equipment, face shield, hazmat suit, et cetera, just in case something is not right. But when you're doing the recycling, it's the same type of thing where you're handling it that way, and they're able to recycle. I don't know what the efficiency is in terms of the recycling, but I know that it's running somewhere around, the 35% efficiency right now that they're trying to improve on. So some parts are recyclable, not all of it yet. Not as much as the VRLA product is.
great. Thank you.
More question?
Any
Anything
other
else?
questions?
Anything else I missed, or
Is my audio okay now?
now it's better?
Okay. I disconnected my headphones and then reconnected.
Ah.
The Bluetooth connection does that.
Hear me. I have a question. Can you hear me?
I can, yes.
Okay, I'm wondering if it's taught, this presentation is available, for instance, on YouTube or somewhere.
We don't have it on YouTube, but what I can do is I can email you the actual presentation material itself. It's a PDF that I can email to Tom, and then he can distribute to everybody.
If Tom would do that, I would appreciate it. Thank
Chris,
you.
we're recording this. Do you mind if we put this up for people to view?
Oh, no, that's fine. Sure.
Okay.
Yep.
It'll be a
Cool,
while. But we'll
thanks.
get it up.
Yeah.
No other questions?
Hey, I appreciate you guys listening, and hopefully it gave you some ideas, or at least gave you some information about kind of what the future is looking at in terms of what batteries can be in UPSs, and help you out at your transmitter sites with less maintenance product. You don't have to go up there. It takes up less space and those types of things. So hopefully at least some good information, or at least spark some interest in now maybe you'll see more and more lithium ion batteries all over the place.
I think it was a great presentation. Thank you.
Thank
Yes,
you.
it was. Thank you, Chris. And
Thank
don't
you.
forget, guys, if you need anything from Seiko Energy Products, Jim Peck is your sales rep.
Thank you very much.
All right.
thanks,
you,
guys.
Happy Thanksgiving,
All
everybody.
right. Happy Thanksgiving, everybody. Thank you very much.
Absolutely.
Thanks, guys. Yep.
All right.
Thank you.
Good night now.
Thank you, Chris.
All right.
Good night.
Thank you.
Yeah, I know.
Good night.